Hello, in this lesson 5.3 we're going to begin to solve equations using the addition property of equality. So what we will do today is we will learn how to isolate a variable so that we get a variable on one side of the equal sign, for example x is equal to, and then we get our number on the other side, for example something like 10. And when we do this, we have a balanced equation, and that's our goal of any time that we solve for a variable, is to have balance. We'll also learn how to check to make sure that we've done the equation correctly. So we have one main goal when it comes to algebra, and that is isolating the variable. But what we do to one side of the equation, on one side, for example, the left-hand side of the equal sign, we have to do to the right-hand side. So this is very important for us to have balance. So our goal is to have x on one side and a number on the other side. And when we look at our first example, x plus 5 is equal to 6, well, we need x by itself on the left-hand side. So we always ask ourselves, what are we doing to x? In this case, I'm adding 5 to x. So in order to get rid of that 5, I'm going to kick it over to the other side. So I have to do the opposite operation. So I'm going to subtract 5, because 5 minus 5 will cancel the 5 out. But what I have done on the left-hand side, I have to do also on the right-hand side. So I'm going to have x isolated on the left is equal to 6 minus 5, which is 1. And we can check using substitution. So where we see x, we can take our answer, 1, and substitute it for x in the original equation. And we ask ourselves, do we have balance? 1 plus 5 is 6, and 6 is equal to 6. Therefore, we've done our solution correctly. So remember, our goal is to isolate the variable, and whatever we do to one side, we have to do to the other. So for example 2, we have y minus 4 is equal to 3. Well, we're subtracting 4 from y, so we're going to add 4, effectively canceling. And because we did that on the left-hand side of our equal, we're going to do it on the right-hand side. That will leave us with y is equal to 3 plus 4 is 7. Now to check, we go back to the original equation, and we substitute what we solved for y into that equation. So y minus 4, y was 7, minus 4 is equal to 3. And indeed, 7 minus 4 is 3, so we have a balanced equation. So let's solve a couple questions together. Remember, the first step is to ask ourselves, what are we doing to the variable? In this case, the variable is x, and we're adding 7 to x. So to get rid of it, we're going to take away 7 from both sides, canceling on the left, subtracting 7 on the right. Now we've isolated x. X is equal to 10 minus 7, which is 3. If we would like to do a check, we're going to substitute 3 back into the original equation. So 3 is where x is, plus 7 is equal to 10. And we see that 10 is equal to 10, so we know that we've solved correctly. For number 2, we have a minus 5 is equal to negative 2. So we are subtracting 5 from a, so we're going to add 5. And that will cancel, right? Negative 5 plus 5 is 0, so that leaves us with a isolated. And what we do on the left, we have to do on the right. We're going to have negative 2 plus 5, which results in positive 3. So a is equal to 3. And again, if we want to check, we can substitute back in that very first equation. Everywhere we see a, we put 3 in brackets. Minus 5 is equal to negative 2. And when we add the opposite, we can see this is the same as 3 plus negative 5, which is negative 2. Negative 2 is equal to negative 2. This equation is now balanced. I'll do a few more of the exercise questions with you. You can pause the video, try them on your own, and then check with my solution. So number 1, we have x plus 6 is equal to 11. So because I'm adding 6 to x, I'm going to take away those 6 on both sides of the equation, canceling out on the left, isolating x, and 11 minus 6 is 5. You don't have to check every question, but once in a while it's a good idea to do a check. Go back to that original equation, substitute what you got for x or your variable, put it into that equation and see if it works out. 5 plus 6 is 11. 11 is equal to 11. You know you have the right answer. For number 2, we're adding 5 to a, so we're going to take those 5 away from both sides of the equation, canceling the 5, isolating a, and 2 minus 5 is negative 3. If we want to check this question, we're going to substitute negative 3 for a, add that to 5 is equal to 2, and see if that works out. And negative 3 plus 5 is positive 2, so we know we've solved correctly. Sometimes the order of things is a little bit turned around. Don't worry about that. Just look at what's happening to x. You're adding 6 to x, so you're going to take that 6 away from both sides of the equation. 6 minus 6 is 0. It cancels out, isolating x. And on the right-hand side, 10 minus 6 is 4. For number 9, x is on the right-hand side of the equal sign. This is also fine. You can have x on either side of the equal sign. So here we're subtracting 6 from x. So because we're subtracting 6, we're going to do the opposite and add 6 to both sides of the equation. So negative 6 plus 6 cancels, leaving x isolated, and 11 plus 6 is 17. X is equal to 17, and you can write it like I'm showing, or you can switch it around if you prefer. X is equal to 17. Sometimes they use brackets, and those brackets don't mean multiplication, and that's the case for number 14. It's x plus negative 3 is equal to negative 5. This actually isn't very typical for algebra. Most of the time you would see this as x minus 3 is equal to negative 5. So in this case, you might want to look at it that way, because what you have to do here is get down to 0. You have to do the opposite. So we're going to add 3 here to both sides of the equation, because negative 3 plus 3 is 0, canceling them out. That will leave you with x is equal to negative 5 plus 3, which will be negative 2. And if you wanted to check this one, you could substitute negative 2 for x plus negative 3 is equal to negative 5. And you can see here that you have a balanced equation when you do your check.